your nose if you catch my drift. All right, maybe some Band-Aids, all right, because it might get brutal. All right, because I know some of your preparation styles. So, all right, that might be, forget about bandanas and cut off sleeves. Bring in some medical supplies. All right, here we go. So you're on page 55 right now. At the bottom in the oval, there's our textbook questions I'm suggesting. There's a ton of questions in the packet to try. Don't get me wrong. But if you need more, go to the textbook. And just so we're clear, there's no answer key in your packet. All the answer keys are on Classroom. All right, you're going to see something that says unit test review material. That's where all your answer keys are. So you'll see textbook answers, packet review answers. That's where you get the answer keys from. Now, maybe you try a whole bunch of packet questions and you're like, you know what? I still don't feel comfortable with law of sines and cosines. I posted extra questions on Classroom. Same with Hills and SAS if you don't feel comfortable after doing the review I provided. All right, so those are two topics I know people don't feel comfortable with. Maybe. So there's some extra questions up on Classroom for that. All right. So here's what you can expect. Let me go down the rundown. First three questions, I don't mind telling you, is multiple choice and they're all law of sines and cosines. Okay, so the first three questions tomorrow, you should be using law of sines and cosines on those multiple choices. After that, the other six are kind of like word problems. Now we're going to go over a bunch today. So here are the topics. Number 2, I put stars next to this. You do not waste your time memorizing the rules for 30, 60, 45, 45, 90. Here's why. You don't need to anymore. Tomorrow, if I give you, kidding, not right now. Yep, there it goes. All right, let's try this again real quick. Okay, tomorrow, if I give you a 30-60 or a 45-45, so let's say I give you a 30-60 here. Here's X, here's 8. You don't need to remember the rules. Here's why. Use SOHCAHTOA. All right, you can use SOHCAHTOA now. Oh, I got the opposite and hypotenuse. I can use SOHCAHTOA. All right, so no need to memorize them. All right, the reason why we needed to memorize them back in the day was I hadn't taught you SOHCAHTOA yet, so we needed to know the rules. Now you don't need to know them. So don't freak out. What I'm trying to tell you is you're going to see a problem tomorrow that's got a 30-60 or 45-45. Don't freak out because you didn't remember the rules. Just use sine, cosine, tangent. You have that available. All right, so SOHCAHTOA. Elevation and depression. Let me just review that real quick because you will have a problem where you need to find one of those angles. So let me give you 2 different triangles right now. All right, we ready? Elevation. You're looking up at an object. So elevation is going to be right here, your angle of elevation. That's your angle of elevation. Depression, you're looking down, but it's not that one. All right, remember, you're standing on top of something with your horizontal line of sight. This right here is your angle of depression. But what did we talk about? How can I get it inside the triangle? I can't use it because it's outside. How do I get it inside? I can do one of 2 things. Bailey. I could say whatever this is equal to this one down here. Or what's the relationship between the one that's adjacent to it? Complementary. They add to 90. So either way. But do not put depression here. It's not the angle of depression we're looking for. All right. So angle of depression, elevation. Pythag. Don't forget about that bad boy. Jeez. All right. That's always available to you. Only if you're working in a right triangle, though. All right, that's always available. And then big old law of sines and cosines. That's any type of triangle, any type. And then I threw this on here, double triangles. I know you have no idea what I mean, but we're going to do 2 examples of those later on in class. All right, so here are all the topics for tomorrow. Look, we started this right after the midterm. So it has literally been almost to the date a month, all right, with a whole break in between. That's why I get nervous, all right? And it's a little bit on the tougher side, too. Right, it's got a whole bunch of material, as you can see. We've been doing it for a month with a break in between, and it's the questions are a little bit tougher. All right, so that's why I get a little nervous, but the review is great. All right, not because I put it together, but the questions are tough. All right, so try the review, try it as much as you can in the textbook too. All right, one suggestion I have for you tomorrow. Take it or leave it. Piece of advice I have for you. Look at the diagram before you even start the problem. So even before you label a side length or an angle measure, look at the diagram, because most likely the diagram is going to tell you what type of problem it is and what to use. Here's what I mean. Let's say the diagram is not a right triangle. There's only two things you can use in this unit that we've talked about, and that is law of sines or cosines. All right, so look at the darn diagram tomorrow. If it doesn't have a right angle, it's either going to be law of sines or it's going to be law of cosines. It's got to be. You can't use anything else I've shown you in this unit. Good? Look at example 2. I know it's been a while, but if I give you that type of diagram, does anybody see any degree measures other than the 90? No. So you can't use SOHCAHTOA. You need a degree measure to do that. What type of problem is this going to be? Where's this fall under? This is a what type of problem? That's Hill-Sass right there, kids. Yep. Hey, the large triangle is a right triangle, and I draw an altitude to the hypotenuse. This is Hills and Sass. All right? And you know that before you even start. Before you even start this problem. Oh, Hills and Sass. All right? Got to be Hills and Sass. Just the way the diagram looks. All right, let's go down to number 3. It's a right triangle. All right, so I got that. Yep. What should I be using here now? Oh, look. I got an angle that's less than 90 in a right triangle. I can use what? This is going to be what? I'm not looking for the exact answer, but I can use what? SOHCAHTOA. Yep. There you go. I know what I'm going to do before I even start, just by looking at the diagram. And then what about 4? It's definitely not the Hill-Sass diagram, and I have no angles listed. But I'm still asking for a side. What's this one? I don't think I can use, here's the problem. I can't use law of cosines. I don't know this angle here, right? You guys are overthinking it. Just Python. All right? Don't overthink it. Remember, Python. 2 sides of a right triangle, trying to find the third, just Python. Don't overthink it tomorrow. All right? Don't overthink it. So just try to look at the diagram before we even start. Look at the diagram. Here's what I'm going to do. We're probably going to go right to the end of class today doing some of these. I picked out review problems that fit almost every single one here. All right, so we'll see how we do. I'm going to start with number 14 in your packet. Review number 14, and I'm going to start calling on numbers here too. You got to, you have to know what you don't know. Okay, before I even start sniffing any words, look at the diagram. What are we going to end up doing here? Hill-Sass. Yep, I don't know which one, but at least I know it's a Hill-Sass problem. All right, there's no angles listed there. Don't write any in. We're looking for BC in simplest radical form. All right, BC. You know it's Hill-Sass, so now how do I decide which one to use? Altitude, altitude, altitude. Look at the altitude. Do I know anything about it, or am I trying to find it? Nope, neither one, right? So Sass is out, because that's the one that involves an altitude. So this has got to be a Hills problem. Altitude is not involved. BD is not involved, so I'm going to use Hills. Whew, it's been a while, but that's why we review. What's the H in Hills stand for, and what is it in this problem? H in Hills, and what is it? Here we go. Been a while since I looked at this, huh? I'll get there eventually. There we go. Finley, what's the H stand for? Hypotenuse. Where is it in this diagram? 12. Good work. When I say H, that's hypotenuse of the big right triangle. L4. It's the L stand for in Hills. Bryson? Leg. Now, I got 2 of them, but I'm only using one in the problem. Which one is it? X. It's the legs of the large right triangle. BA is not being used. I'm using X. You guys know already the L's and Hills are the same. And now here comes the big part. You could fall into a trap. What's the S stand for in Hills? Shoo, Finley, back to you. The S? Segment. You got 2 of them. Hey, we got 2 of them. I got DA and I got CD. But we use the one next to, adjacent to the leg being used. So I don't want to use 8, even though it's labeled. I want to use the other one, CD, which will be 4. Okay, so S, segment next to the leg. Cross multiply. Your calculator will give you your answer in simplest radical form. So x squared equals 48. Yes, take the square root on both sides. And what are we looking at there? 4 radical 3. There we go. 4 radical 3. Questions from you guys? Questions going? All right. Let's tackle first problem on there. Number 1. I'm not going to give you any quadrilateral problems, so you don't need to remember properties, but I am going to need the properties here to get us going here. So label your rhombus ABCD. Side length of 10, doesn't matter which side I put 10. Nope. All sides are equal in a rhombus. Angle A is 60, and we are in charge of finding both diagonal lengths. And the diagonals are not congruent in a rhombus. That's a rectangle. Diagonals are not congruent. All right, so let's draw both of them in, I guess. Let's draw both diagonals in. All right, here's where I need your help with the properties. And again, you're not responsible for any properties tomorrow. I'm not going to do that. I would have warned you. It's not on there. But in this problem, I do need them. Anything you know about a rhombus that's going to help me out here? So I can start labeling my diagram a little better. Cormac, one thing?
The right angles or the diagonals are perpendicular.
Yep, so here you go. Diagonals are perpendicular, so that's where you get your right triangle from, right there. All right, I need a little more. Another one, definitely. About the diagonals. They are perpendicular. Dylan? They bisect each other. That'll come in here in a second, not right in a second. And then the other one, they bisect the angles. All right, so see this 60 degree, what's it turning into? 30 and 30, right? All right, yeah. I know, right? That's a 30, 60, 90 triangle, but we don't need to know the rules. We don't need to know the rules. All right, yeah, you're right. That's a 30, 60, 90, but I don't need to know the rules. Make a class decision for me here. Tess, what diagonal are we going to find first? It doesn't matter. BC it is. BC? AC? All right, we're going to find diagonal AC, everybody. Can't do that, though. I'm not going to be able to find the whole diagonal AC, but Dylan, what was your property again? How about we just find this piece and double it? Okay, there's no way you're going to find the entire diagonal AC, but I can find half of it and then double it. All right, you ready? How am I going to find that piece now? Not Hills and Sass. It's a right triangle, though, so I don't need law of sines and cosines. SOHCAHTOA. All right, so tell me what the x and the 10 are. Opposite, adjacent, hypotenuse to the 30 we wrote down. What's the x and the 10 here? Jonathan, what's the x?
Opposite. Adjacent.
Adjacent, what's the 10?
Opposite. Well, hypotenuse.
Hypotenuse, it's across from the right angle. Adjacent, hypotenuse, which ratio are we going to use now of the 3? Jonathan again. I got A and H. Sine, cosine, or tangent? A and H. Cosine. Everyone ready? Cosine. 30 equals adjacent over hypotenuse. And then hopefully we know where to go from here, right? I'll put it over 1. Directions, go back to the directions, simplest radical form. So no, I don't want that decimal on your calculator. Use the radical. Which one's this? 5 radical 3 or 5? 5 radical 3. Only half though, right? We just talked about it. That's this part. Dylan just said it gets bisected, which is correct. So AC, I'm going to double that. And your calculator is giving you 10 radical 3, hopefully, for diagonal AC. All right, ready to find BD now. Same process, right? But find half of it and double it. Find that one. This is what I love at this point. There's a lot of ways you could find that one. Find that half piece. We could do Pythag, right? If we wanted to use 5 radical 3 and do 5 radical 3 squared plus y squared equals 10 squared. I'm going to use SOHCAHTOA again. The y is opposite now, isn't it, of the 30? So now let's use, instead of cosine, sine. Could you use tangent if you plugged in 5 radical 3 and done opposite and adjacent? Yeah, you could have. That's what you could use sine, tangent, Pythag, anything to find y. So sine of 30 equals opposite over hypotenuse. You could use anything here. Cross them up. This one's 5. Double it because it gets bisected. BD. All good? I'm not testing you on the rhombus properties. It was right here. Finding a side using sine, cosine, tangent. That's what I'm testing you on. Ooh, all right. Next up, number 2. See what you got here for me. Little rectangle. The 8 and the 6, put them wherever. Put in whatever diagonal you want. All right, put in the 8 and the 6 anywhere you want. It's not going to matter. Put in whatever diagonal you want. Here's the part that matters. We're finding the angle the diagonal makes with the longer side. So look where the diagonal and wherever you put 8 meet. All right, look where the diagonal and wherever you put side 8 meet, and that's the angle we're trying to find here. So there it is for me. Might be somewhere different for you. I don't know if I've been doing a good job getting this through. We are finding a what here? Let's say that again. We're finding n. We are? We're finding a diagonal? Thought we were finding an angle. Angle? We're finding an angle. We are finding an angle. What eventually is going to happen here? Shift. Yes. Right? I don't care what we're using. If you're finding an angle, we're going to end up with the shift key at the end. But how do we get there? All right, I know I got to do shift something at the end, but how do I get there? Well, what do we know about a rectangle here? Right angle, yep. If that's 6, this is 6. Yep, I got that. All right, what are we going to do shift with? Sine, cosine, or tangent? Figure it out here. What's the 6? Opposite, adjacent, hypotenuse. Okay. That's my... Label the 6 and the 8 for me. How about that now? Label the 6 and the 8 for me. Brendan, what's the 6?
Opposite.
It's opposite. How about the 8? Adjacent with those two values. Which ratio can I use now? Who, Vinny?
Sine. Tangent.
I don't know which one.
Tangent.
Tangent, right? TOA, T-O-A. So tangent of x equals opposite over adjacent. Are you going to cross multiply? No, that's your right there. There's your shift button right now. Shift tangent, there's your ratio you plug in. All right? Shift tangent, plug in the ratio. We don't cross multiply when we find an angle. And what is that, 37 if I remember from first period, or no? 31, 37? 37, good. So we'll be ready to find an angle tomorrow. Oh, I got to use the shift button. We're all good? Whew, a lot on there tomorrow. All right, remember the last topic I put on there was double triangles? Right, double triangles. I'm going to throw one of those on there tomorrow. And here's what I threw plenty on your review, but we only have time to do 2 of them. 13 we're going to do. First one's 13. I don't want to blindside you. All right, I don't want to blindside you, so I'm telling you what's on. It's on there tomorrow. Except I think there's like a campfire, a lifeguard chair, something, I don't know. So there it is. We got the height of find the height of the building. And there's one other piece that's not labeled, and that is the person at B is 100 feet closer to the base of the building. So here's your 100, guys, right here. All right, tomorrow I will label every single part of the diagram. You don't have to worry about labeling it on your own. So there it is. Find the height of the building, and from A to B is 100 feet. Whew. And if you're wondering, yes, you can assume that ACB is a right angle. That is a right angle, yeah. All right, let's take this slow now. How can I find X? How many right triangles you see here? How many right triangles you see in this diagram? 1, 2, 2, right? So let me go to the smaller one. Everyone look at triangle DBC. DBC, right? This one right here. I have 55. What's the X? Opposite adjacent hypotenuse. That's opposite, right? But the problem is, everyone see the problem? I don't have another side. So I don't know if I can use sine, if I use tangent. I don't have another side. That's a problem. All right, you guys said there was 2, right? So let's look at the big one now. I got 45 degrees. X is still opposite. Can I use the 100 here now? Can I use the 100? Some of you are saying yes, some of you are saying no. Is it a side in this right triangle I've just highlighted? No, you can't use it, right? You only can use full sides. So does everyone see the problem I'm having? I have the opposite side, but I don't have another side to do sine, cosine, or tangent. That's a problem. All right, well, we went over 2 triangles already. There's a third one in this diagram, right? Which is this one, ABD. Is that a right triangle? Is that where? Ooh, no, it's not. It's not a right triangle. And you remember my problem I had with the small one and the big one? I was missing a side, wasn't I? Oh, wait a second. Isn't this a side right there? That side DB. That's a. If you guys could help me find that side, then we could do sine, cosine, tangent on the smaller one. See our plan right now? All right. So can you find side Y for me? Can we find side Y? You told me a minute ago. Is that a right triangle? So guess how we're going to find Y if it's not a right triangle? Either law of sines or cosines, one of them, right? Okay. All right. So let's see here. Can you guys find? I have 45 degrees in that triangle. Can you find any others on your own? Yeah, go. I think you could find the remaining 2 in that triangle. Go. Find the remaining 2, and then we'll start rolling. Find the remaining 2. Let's see, the one next to 55. Oh boy, 125? Well, we got a tiny one up top, right? What was that, 110? Whew, all right. So you guys decide, sines or cosines? We've got 3 days of this now, and it's sines or cosines. Do you have 2 or more angles? So we can use law of sines. Yeah, we can use law of sines. Set it up for me now. Someone's going to set it up. Law of sines. This over this equals this over this. Only use values from that triangle, though. All right, I shouldn't have 55 in here. Only use angles and sides from that triangle. All right, what do you want to start out with? Side and an angle across. Side and an angle across. Cormac?
Is it 100 over sine?
I'll take that first. Perfect. 100 over sine 10. And then what's the other side going to look like? There we go. Zoli, what's it going to look like?
X over sine of 45.
X isn't in that triangle, though.
Y.
The Y here, yep, over sine of 45. There we go. I like it. So that'll find that side. Let's cross them up. Hey guys, real quick as you're calculating, is this going to find, is this the height of the building, what you're finding right now? No, and I asked that because I don't want you to round it, right? I don't want you to round it because it's not our final answer. let's see, where did I put this? 100 times sine 45 divided by sine 10. All right, here's what I'm getting, 407 and some change. Yep. All right, that's side BD. Now remember why we needed it. Now go to the right triangle, DBC. We now have opposite, and what did we just find? Hypotenuse, right? We had opposite was at the height of the building was opposite, and now we just found the hypotenuse. So we're going to use sine. And what's my angle measure? I'm going to go from here. 55 now. So sine of 55 equals the height of the building over, and you can just draw an arrow. I always do. The hypotenuse. What's the nearest hundredth? So 2 numbers after the decimal, everyone, 2 numbers. I got 5/6. That's what I mean by double. We're going to do another one, but this is what I mean by double triangle. You are not going to be able to find the value in one step. You're going to have to find another side to get to that value. All right. All right. There's a ton of double triangles in your review, but I want to do one more with you, number 6. Everything's labeled for you. All right. Everything's labeled. We're finding the distance from point A to D, nearest foot, from A to D. So here's where your thinking process goes. All right, look at the triangle AD is a part of. Is it a right triangle? No, right? So I'm going to have to find AD by doing law of sines or cosines. And I see some of you right now, great, find more angles, right? You can find more angles in that triangle. Let's find more angles, the one next to the 16 and the one up and the third one. So 9 degrees. Oh boy. 164. Yeah, 164 there. Thank you. All right, but remember, hey, I don't think you can do this in one step. Here's why. If I'm looking, everyone look at triangle ADB. I see if I try to do law of sines, because I have 2 angles, I have x over sine of 9. I don't have a second side. I'm not ready to use law of sines. But can anybody use another triangle in this diagram to find a missing side in that triangle? Can you help me out? Can you find another triangle to help me pop in a missing side in triangle ADB? Can you find another side using another triangle? How about this triangle here, BDC? How about we find this? That's, oh, I don't want to call it X. How about we find that side right there? And we can use that in law of sines. Can you? Can you find that side? I hope, yeah, it's a right triangle. All right, we can use sine, cosine, tangent. So here we go. Drew, what's the 125 from the 16? Opposite, and what about the side we're trying to find there? That's the... All right, so Drew just said you have the opposite and the hypotenuse. I think we can use sine to find y. Sine of 16. Opposite side over hypotenuse. Hey, was anybody thinking using law of sines on that triangle too? You could look, you could go y over sine of 90 equals 125 over sine 16. You could do law of sines there too. All right. Oh, what do I get here? So you had that side, and the reason we found that side because we needed another one in law of cosines. So now I'm going to go back to triangle ADB and use law of sines again. Remember, I could do x over the sine of 9. And now, here's that side I was missing. And what am I going to put that side over now? What should that look like in law of sines? It should be 453 and change over... What's the angle across? Make sure you use the same triangle. Not here. Alexi, over. What's that side across from? The x is across from 9 degrees, so that's why I put sine of 9. That hypotenuse we just found is across from. Oh, you're using a different triangle now. All 4 values have to come from the same triangle, ADB. So I got x over sine of 9, right? X across from it is 9 degrees. I just found this value. What's it across from in triangle ADB? 7. So I got to go sine 7. Remember, all values have to come from the same triangle when you use law of sines or cosines. All values from the same triangle. Nearest foot, 582. Questions there? So again, I know I spent a lot of time on just one question on the quiz tomorrow, but I want to at least expose you to it. And there's more in there. All right, there's a lot more in there. Real quickly, can you go to number 10? The diagram's not labeled for you, and I don't think that's fair, so I wanted to label the diagram for you, because that's what I'll do tomorrow. So again, another double triangle problem. 125 goes right here. AB is 125 feet. And my 2 angle of elevations, at angle A, it's 43 degrees. And over here is 77 degrees. And you're finding the height of the building there. All right, so another double triangle. Don't start it. You know, you got plenty of time on your own. I do want to ask you one question as a class, actually a couple questions as a class. Let's say I give you this triangle here and I put 6, 8, and 9 as its sides. And the question is, find the smallest angle. Find the smallest angle in that triangle. Do you have to find all 3 angles and just circle the smallest one and waste your time? No, I hope not. Because you already know, where's the smallest angle going to be? Across from 6, the smallest side. Good. All right. There's half the battle, knowing that you're trying to find this angle. How do you find that angle? Is this a right triangle? All right, so that should help you out a little bit. It's not a right triangle. So now you're down to what? Sines and cosines? Which one here? Law of cosines, right? Yep. All right, and so now you know it's law of cosines. Do you start it out with 9, 6, or 8? There you go. 6 squared plus, equals. And if you're finding an angle, what's going to happen at the end of this? There you go. Right, you're going to get this by itself and do shift cosine with whatever that decimal is. Yep, good. All right, so I just wanted to throw that out there. I didn't want to see anybody, if it does come up tomorrow, finding all 3 angles and then, circling the smallest one. All right, waste of time. You already know where it's going to be. All right, guys, that's all I got for you. All right, I can only serve you. I can't feed you, make you eat. All right, so it's up to you guys now. All right, I will be here after school, so you guys know the deal. We still got a few minutes, but